So as we present today, please put any comments or questions or anything that you have into the chat. Both Luca and I will monitor it, as well as our helpers, Kevin and Mark. So we want to make sure that all of your questions get answered, even if you're not raising your hand or having input like that. So please put anything you want, any questions you want into the chat. So we're going to get started. So today we're going to talk about preparing for AI-driven research on ScHARe. We're going to talk about not only a review of the last 3 sessions, which was about common data elements, AI-ready data sets, and computational strategies. We're going to also add what we have to do to prepare for transparency and the kinds of documents that we need that are a little bit different than regular research on not using big data, not using AI, because we really want to perpetuate ethical AI, and we don't want to do things that create more biases and more harm, especially to the vulnerable populations that we are researching. So that's today's session. ScHARe is a platform that was created in conjunction with the National Institute of Nursing and the Office of Data Science and Strategies. Of course, there's been many people that helped put this together. Also, new partners to this is the Office of Research on Women's Health and NIDCR, which is the Institute for Dental Cranial Research. This is what we're going to be covering today, as I said a little bit ago. And then next time, next month, this is what we're going to do. And then in the month of April, we're actually going to start research projects. So some of you are new. So we always do this really quick overview of what ScHARe is. It's a cloud-based data platform. It's really was designed to increase women and racial ethnic populations into data science, because there is a lack of both of those in the field, both of those populations. We also hope to create a paradigm shift in how we think of research in health disparities, because you get a different opportunity when you use big data. You have more information. And of course, we want to advance bias mitigation and ethical inquiry. And the other thing that we aim to do, which came about a little bit later, was really become a resource for community colleges and low resource minority serving institutions. The components of ScHARe is we have data sets. It has a data repository, several computational skill abilities and tools for doing all sorts of analysis. We are also adding SAS. It's a Google platform. That's why when you register for ScHARe, you need to have some type of Google email. It has a Terra interface, which is important, as I will explain later. And we also have NIMHD web page where you can both sign up for ScHARe and Think-a-Thons, as well as view all of the posted Think-a-Thons. So Kevin or Mark will put in the link for all the past Think-a-Thons, and that link will also be where you will see this presentation in a couple of weeks. And the reason we say a couple of weeks is because we have to make all of the slides 508 compliant, which means it's for all the disabilities. So sometimes it takes a little while for us to get all of that done. In the data ecosystem, and we're going to cover this a little bit more in detail when Luca talks about it, but basically we have over 240 data sets. We focus mostly on population science, including the social determinants of health, as well as health behaviors, and some disease and conditions. We don't spend a lot of data storage and disease and conditions because we can link to other platforms and get that information. One of the things that we are very proud of is that under the, and I'll talk about this a little bit more in detail, in the ScHARe repository or the ScHARe funded data sets, we're also using common data elements so that we can link project data to federated data. Our repository is CDE focused, and Luca's going to go over what CDEs are in case you missed that session. He's going to go over it in brief. It's basically a standardized way that information is collected. And in that standardized way, there is a standardized concept definition and a standardized code. These two things are critical for common data elements, especially in a repository like this, because we use what this kind of new approach, which is a URI approach, meaning we use the codes to help integrate the data sets. These are the ScHARe CDEs that are being adopted. They, the two NIMHD framework and health disparities outcomes are done at the project level. The rest of these are done at the program or personal level. Oh, I forgot to mention, these CDEs are now, they are NIH endorsed, which we're very proud of because we're one of the first sort of institute level CDEs that have been endorsed. And they can be found in the CDE repository. You don't have to worry about writing this down. You're going to get the slides so you can get all of this information. The reason this is important is because when we deposit projects into the repository, it's going to be based on the common data elements. And this interoperability and data harmonization is what CDEs help with. And it's why those codes and concepts are so important, because we're going to create those linkages using those codes, because there's many different coding systems. So one coding system's not better than another. So it's easy then we use the NCIT thesaurus, but there's link codes, FHIR codes, and we're going to link the codes together for the interoperability of the data harmonization, data aggregation. As I said, we're linking projects to federated data sets so that you can bring in federated data sets into your project data, which will help us do AI types of research. And we used a Terra interface. What's important about the Terra interface is that these other platforms, which are big at NIH, they do more of the basic sciences. All of us does a little bit of both, but mostly genetics. So by having a Terra interface, we also create a merging across platforms so that people can take the social determinants of health information from ScHARe and move it into Biodata Catalyst or Anvil or all of us, which is beneficial since it's the only repository that actually has social determinants of health major data sets. When we create the repository will be open probably late summer, and it's based upon the ScHARe CDEs. So you will be able to look at how those CDEs emerge in the different data sets. As I said, we use a Terra interface. And what's important about the Terra interface is that it has secure workspaces. So in a secure workspace, you can go on there, you can have it all to yourself, or you can share this with other people and give them rights as well. We're not going to go into all of that, but we just wanted to show you the capability of the Terra platform. And you can assign the roles that you want your users in your collaborative workspace to have. They can be readers or they can be read and write, but you own that workspace. We've also have notebooks under analysis, and in these notebooks you get basically copy and paste code, so you don't have to keep coding or reinventing. You don't have to know code. You can actually cut and paste it, and there's several tutorials that we did teaching you how to do this. Look on our webpage. Right now we have close to 2,000 users, so we're growing fast. And as you know, we've done these Think-a-Thons, and we're moving into the research Think-a-Thon, which will start in April. And the reason that we're starting to do this is we're going to start with secondary data analysis. So we're not going to be collecting data. We're not doing clinical trials. We're actually doing secondary data analysis. And what we hope to do with these is to show you, even in these data sets, you see much information about social determinants of health and health disparities research are all in here through meaningful looks at the data in big data. And it will help us to create this paradigm shift in health disparities research in order to use combination of different data sets into health disparities research. One of the benefits of a secondary data analysis, of course, it's cost effective. You only use the sets that are already there. Of course, there's time efficiencies. All of the data sets in our repository have race and ethnicity. That's one of the criteria for inclusion. And of course, you don't have to worry about PII. That's personal identifiable information. And I'll go over this in a little bit. This is why this session is going to start with what you have to do in big data AI research that is somewhat the same, but also somewhat different than normal types of research documentation. And we'll start with kind of the normal research documentation and then move into AI documentation. The reason this documentation, and you have to know this up front. So we didn't want to start the research project without you having a clear understanding of this type of documentation, because it is truly this lack, I'll repeat that, this lack of documentation that creates the biases and the lack of transparency in what we're experiencing now in AI use. One of the benefits of it being transparent is that we can reproduce results. We know the accountability of the stakeholders. It can foster collaboration, but most important, it can tell us where biases have emerged and where they can be mitigated so that no harm is done to diverse populations. One of the things that I want to really stress here is that without this type of documentation, it is very difficult and dangerous. Not difficult, it's dangerous to apply AI in a generalizable way without knowing this kind of transparent information that I'm about to cover. So let me start with the laws and regulations or guidelines dealing with AI and machine learning. Globally, you can see from 2016 to 2022 that it has risen. But if you look at the number, it's only 37. And most of these are done in Europe, not in the United States. So if you're interested in looking at some of these, the European Union and the Turing Institute shine the way for ethical AI. They've developed many of these standards and regulations that the United States has not developed. And for those of you who are interested in doing more international research, especially using data from the European Union, they have this general data protection regulation now, and it is very difficult to get the data because of the privacy issues around it. So I just wanted you guys to be aware, and there's 2 links on this page. If you're interested, you can dive in deeper. Notice that even though the regulations and laws are minimal, and notice that it was globally, the United States is investing billions in AI and R&D. And notice that this is non-defense. So this does not include what the United States is doing for defense AI. So it is an important endeavor, but the United States lacks information. Sorry, wrong slide. The United States lacks information. They lack the laws and regulations. However, there are some White House initiatives coming out that look at the governance of this, and the links are on the page. I don't want to go through all of these or what they mean, but there are some efforts that everyone is trying to do to catch up actually with the European Union. So it's not that nothing is being done, it's just that we don't currently have it. These are some of the guidelines for protecting Americans' privacy and advancing equity and civil rights. So this is being approached in a thoughtful way with diverse population perspectives. It's just not implemented. So what's happening is several federal agencies and federal organizations are trying to do it on their own. So CMS started with this challenge. And what they're trying to do is learn what kind of methodologies and restrictions and et cetera could help with Medicare, Medicaid data. And after this, then they will move into trying to define the regulations. FDA has focused on medical devices mostly. There have been some for software, but in general, these are the only 2 areas that they've established any type of guidelines, regulations, or laws. NIST has been charged by the White House to develop a risk framework for AI to improve trustworthiness, which they did release. And they're now being charged with the task of creating guidelines, protocols for cultivating trust in AI technologies. One of the things that I want all of you to be mindful of is that these efforts are not very comprehensive for health. So as you see these RFIs come out and look at your ability to read these and provide public input, it would also be important to make sure that health issues are included in all of these standards. Because the federal government is slow to do this, states are coming up with their own laws and regulations. Mostly their state types of laws and regulations are dealing with privacy concerns and handling of different personal data. In California, the fact that OpenAI, Microsoft violated privacy rights by using all the social media data blog posts to train their models, it actually violated people's privacy. So there's a case going on in California. These court cases will set what we call case law, so that they will have an understanding of kind of what kind of laws and regulations need to be put into place. There's also in Delaware, a court case for Getty, the stock images were used to train AI illegally. So they're using that. And the other part that's important is the dark patterns. So as you hear on the news, many systems are having basically what they call fake news or some type of manipulation of AI in order to change perspectives or create false images. I think the one that hit the news the most recently was something with Taylor Swift holding for Trump signs. So these kinds of things, they're called dark patterns, and they're really coming down and trying to cut down on these things. So laws are emerging in Colorado, California, and the Federal Trade Commission. So first, we have to start with consent. This is an emerging problem with consent because AI is opening up a whole different level of consent that we haven't had to deal with before. But I just want to make sure that for some of you who are more data scientists, for those of you who are researchers, you know this. For those of you who are data scientists, you may not know this. But PII is anything that is personally identifiable information. This is the column on the left are high-risk information, and everything has to be done possible to protect it. So for those of you who are data scientists, and this is oftentimes your falls under your auspice of care, is to find ways to de-identify this information and to use honest brokers, or to make sure that when this information is in systems that no one can get it, that doesn't belong to it. The second column is what we call non-sensitive PII, but there is still some risk involved, so it's handled also very carefully. It's not, it's harder to come back to one individual using these, but it is still possible. So we still take precaution when looking at non-sensitive AII as well. So we do everything that we can. So this is one of the things that you have to put in your mindset to protect individuals' rights to privacy. I said this is a little bit different. Before, most of our consent process was dealt with clinical trials, and we even use now, for those of you who are researchers and get data sets, oftentimes you have to sign data use agreements. And those data use agreements are really based upon reasonable expectations for the reuse of the data. Very similar to whatever the data was that was collected. Consent for data AI use and reuse is changing the scale, because these data sets are on public platforms now. And even though you may sign a data use agreement, you can also share that data and combine it in ways that also create the ability to identify people. So it's changing the landscape of consent, but it's really important to figure this out. And I'm telling you, we don't have it figured out yet, because the data AI use and reuse, it helps us to understand the etiology of the disease. Big data helps us to do novel predictions that we were never been able to do before. And it can also create novelty ways, especially machine learning, because it teaches itself. And as many of you who are genetic researchers, you know that machine learning identified many more genes and SNPs than we first imagined was possible. So there are things that happen with this, that with machine learning, that we can't even know how to consent for. because we don't know what it's going to reveal. But we do have to make sure that we protect the participant, and we can find a way to consent for the reuse of this data. But like I said, machine learning is creating novel findings and causal relationships beyond those that are even predictable. Therefore, the unpredictability of consent and what will be reviewed or revealed is, in our current ways of consenting, is not adequate. So there are many people that are thinking of this. The other aspect that has changed sort of the consent world is we live in a world of datafication. That means all the social media, your telephone, all of your buying habits from your credit cards, your healthcare system collects data, your employers collect data. You have security cameras everywhere you go in parking lots that is collecting data on you, and all of the marketing that happens because every website you go to, or every credit card you use, or every check you write is all a form of data collection. None of this data collection has your consent, or they might have said something and it's a blanket consent form that you just clicked without even reading what could happen. However, what we want to make sure is that when we do this kind of research, that we do no harm. And some of the harms that can come about is that insurance can use this kind of information and discriminate. There can be discrimination based upon disease and disorder information. And a person individually could be put at risk because they don't necessarily want to know the results of some of their like genetic testing or prognosis of their disease. So we have to keep the user in mind always. And as we do consent, this is a plagued problem from the beginning of consent. Even with one clinical trial, is health literacy. Well, not only do we have to deal with health literacy in AI, but we also have to deal with technical literacy and what it means for a machine to use their data to create more data. So it's a complex problem now. And it's very hard for us to explain this to an everyday citizen on the street that doesn't have the vocabulary, doesn't have the real understanding to what is actually happening with the use of their information and the use of their data. And we want them to be informed, but not scare them. So there's the balance. And as I said, this has emerged as a bigger problem because, as many of you know, if you've been in research, there is now a data sharing policy that went into place the beginning of this year. And therefore, many data platforms have emerged, and you're required to put your research on these different platforms and to make data public. Once the data becomes public, you now have the risk of PII, and you have the barriers of using this data because of the data use agreements and the many layers that go with these data use agreements, and does it really apply to the reuse or repurposing of the data? And another really substantial problem, especially for minorities, is the creation of synthetic data. So just real quickly, what synthetic data is, for those of you who don't know, it's when you take a sample size, let's say of 10 people, let's say 10 Eskimos, Alaska Natives, and you don't have enough to actually do the results from a study. So you create, everybody should probably understand this, where they're avatars. In other words, you can create 1,000 based upon this 10 or 10,000 or 100. There's no limits to how many people you can synthetically create based upon a subset of real data. And they use this form in now when there's lacking or missing data, especially for minority groups. So this is a very important issue. Consent also depends upon your perspective. If you're the data controller, you're more concerned about the recycling, the repurposing, and the recontextualization of data. If you're the subject, if it's your data set about you, about the subject's perspective, you're more interested in the data sharing or data disclosure, the data portability, meaning that can it be used across different devices or different platforms? And of course, your right not to be included. So these are kind of NIST standards now, and I didn't use their exact language because I wanted to make sure you understood this in what is currently in place. We have different levels of privacy now for these platforms. We have the most permissive, which is typically federated data sets or no PII at all, like American Community Survey that has no PII. Federated data sets are those data sets in which it's open for public use, but no PII is there. Another level of privacy that we have is moderately permissive. This is where oftentimes the limited PII or the non-sensitive PII is housed. There, as I said, there are some risks there. So there is limited sharing and reuse. And the least permissive platform rating or data set rating is when there is risk PII. One of the things that we have to struggle with as we come up with this is balancing the benefits of big data with the personal data collection. So one sort of assumption is done, and this is where data use agreements come into place, and they raise the consciousness that as you stay close to the intended consent of the data subjects, you can kind of apply the same consent when you reuse it. But the further away you go from the original consent, this is where we are struggling with what are the data subjects' rights and where are the laws and limitations to what you can do as you get further away from consent. I told you there are many people trying to figure this out. These are some examples of AI consent approaches. One is blanket consent, meaning that you just sign something that says, yes, you can use my data for anything that you want, as long as I inform you the nature of the research that we're going to be doing. Broad consent means that I'm giving you permission to use my data for all purposes with no constraints. Dynamic consent, this is when we look at it for specific purposes. And so you go back to the original consenter and you ask them if you can use it for Y, even though they consented for X. This is very difficult to do because oftentimes you can't find the subjects. Oftentimes subjects aren't willing to give this blanket consent, and they're also refuse to have their data used for other reasons. So dynamic consent is, although a viable option, it's not very feasible. And then the next one is meta consent. And basically what they're saying in this is that the consenter can pick many different ranges of research options and then provide a smorgasbord almost, where the user can pick which of these that they allow their data to be used for, and they can opt out of other things that they can that they don't want their data used for. So this challenges, though, machine learning approaches, because we don't know necessarily where the learning will occur or how far it will go. So the difference between broad consent and meta consent is that they pick and choose. Broad gives them everything. One of the other approaches to this that they're talking about is to create something called societal consent. Basically, what it means is that we offer consent, understanding that data is being used for the social good, for the benefit of all, for the advancement of healthcare. The problem with this is that our society is not caught up to that idea yet. And so it's very hard for them to grasp that kind of approach. So right now, it is not a stage for societal consent. So one of the premises that we are really striving for with consent is that if we put too many constrictions, too many restrictions on the data, it inhibits the use of the data for AI. And think about this in the data sharing spectrum. And as we try to share different people's data sets, and many of you who are researchers, I know you've already confronted this problem. When you have these data use agreements, to get through the barriers of the data use agreement and the time it takes in order to get access to that, it's very cumbersome. So one of the things that AI is trying to move to is to the principle of collect once, use many times. And this, of course, will optimize the benefit of data collected, but it does create the challenge of privacy concerns. And it also raises concerns about the trustworthiness of AI. And one of the things that we have to be careful of is not to overpromise. And what I mean by that is, for those of you who are already in the AI field, you know that many advances has happened in cancer, AI's use in cancer, and they've done remarkable things like with skin cancer and breast cancer, prostate cancer, brain cancer, but they haven't had the same types of successes using AI for like Alzheimer's. So we can't make blanket statements that societally, AI is good for all. And for those of you, we also, in data science, you know that we also are moving to this open source AI and machine learning. What this means for those of you who aren't data scientists is that there are platforms like GitHub and Google Gemini. And what it does is it takes code from AI and it places it on the internet. And everyone can come in and change information. I think many of you, even if you're not into AI, you probably have had some experience with Wikipedia. It's that same kind of concept where you start it and then people can come in and add information, document it, etc. This raises a lot of concerns because we don't know how to deal with open AI data privacy. Licensing and open source issues are arising daily in this approach. We also don't always know where the intellectual property happens, because let's use the example of code was written to create synthetic data from the 10 Native Alaskans that I talked about, Eskimos, and they created 100 synthetic data. And then somebody used that synthetic data to create a tool that actually caused harm to the Alaskan natives. who's responsible for that? Who has that who holds the intellectual property, and who's responsible for the harm? In these open source ways where it's iterative and built upon each other, it's very difficult to, as you can see, many of these challenges are arising with AI. Although it sounds like I'm anti-AI, I am not. I am only presenting these things to you because these are things that we have to pay attention to. So we create ethical AI. Not that we avoid AI, because it does remarkable things and we need to use AI. However, we need to stay conscious of these types of things so that we can build ethical AI. So one of the things, and I'm going to have you log on to Slido now. Kevin will put in the link again for those of you who might have started later. So what I'm going to ask you all to do right now is to basically answer this question. What are the best ways to engage with the public to sort of mitigate this tension between using AI and their private information? Because there are many health benefits because of AI, and AI can have unforeseen uses. What are some of the ways that this tension can be mitigated? Or what do you think we need to pay attention to in order to do this? So Kevin's going to show you that you can type in your responses. And if you see a response that somebody likes on the screen right now, you see the little 0 with the little thumb up. You can just click on that thumb up and it will increase, and the top level ones will rise to the top. So please add more. You don't have to type in something that's already been there. You can just click on it. And I hope you guys are all reading along, because some of these are very good suggestions. And it's also things, as we start to do AI research, our health disparities research using AI, especially since we have vulnerable populations that we are looking at, we really need to make sure that we try to include many of these kinds of things that are being suggested. And you can also include them in your grant proposal. And I see the legislative and policy piece. There's, like I said, there's little to nothing in place now. So that's part of the challenge that is happening, because we have nothing when things are violated with AI, it's hard to know who's responsible. I appreciate the Slido piece. I'm gonna open up the floor. I'm gonna ask you to click on your mic, unmute, if there's something really pertinent or anything you want to say that can really make a difference here. to please speak up. If not, when you're done, just hit mute. Or if you feel more comfortable, go ahead and type it in. But this is a very important issue. So I want to hear your voice if you want to say something or raise a question. So unmute yourself and speak up. Uh-oh, we put everybody to sleep.
I want
Hi,
to
doctor.
comment on it looks like have trust in community leaders and educate the public. I think that's a great idea. I think the challenge for me is who's a trusted community leader? And how do we define that? And how do you verify that what they're saying is actually correct? And the reason I'm asking these questions is because before COVID, I would have said anything about diseases, CDC is who you go to. Post or in the middle of COVID, not so sure. So that doesn't really answer the question, but it begs, it kind of addresses the issue of why I think this question is so difficult to answer.
Yes.
Can I just piggyback off of what Kimberly just said?
Yes.
So I might mix up the way that I'm saying this, but I hope you get my idea, is that when you're talking about ideas like this, like there's no accountability that's worked out prior to, because once it happens, right, and once it starts being used in this way, then there's bound to be problems, but there's no accountability, right, that the public can see is already put in place prior to this happening. So then afterwards, even if there's problems that occur, or like what you were pointing out earlier, like injury to certain minority groups or what have you, no one's accountable. And then it's just like, well, they're left with the idea that, well, we should have known better.
Yes, that's why I wanted to make sure that everyone understood that there's little to no laws, regulations that anybody is held accountable for. But it doesn't mean that we shouldn't do AI. But those of us on this group, we have to do it in a different way that is transparent and ethical.
One thing I can say here, if I may talk, is that definitely we have to make sure that the reference database that the AI uses to predict or to gather knowledge, that reference database has to be diversified and it has to be representative of all groups. That's where we should really stress our.
I'm going to cover that soon.
If I could piggyback on that as well. Oops, wait a minute. My microphone just dropped. Okay. Just two things on that. One is that we have a really short period of time to get the word out and make this trustworthy, because once, and already, as we all know, there are a fair amount of press on the hallucinations of AI, and it's losing the public's trust. And, public trust right now in health is really precarious. And so it's behooving to us to fix that up front and educate. And that brings me to jumping on the second one about, well, who are the community leaders? And that's basic public health population, care of populations, is that we have to go into our communities and find out our stakeholders locally, and then look to our local public health departments. The CDC guides, but the local public health department is what, puts out what the local population needs. But otherwise, it might be that the best stakeholders are down at the hair salons or the barbershops or the favorite gathering restaurant, and the people who are local in the community are the ones who are going to know that. And that's where we need to go back to just public health 101, population care.
Absolutely. That is the key right there that will unlock so many other avenues for us. I mean, that's where I start. I start with my inner core family, and I want to know what they think about it and get their spiel on it and get their support too, because that's huge for me. And then go from there with their inclusion in where I'm heading at, as far as the AI information.
I agree with you. But one of the challenges also that AI brings to sort of that community engagement
Mhm.
is that our community leaders don't always know AI either. So there is an education that also has to happen
True.
in order to make them effective at the table.
True.
And if
Well,
I
and
might
that's
add,
exactly what I was
I'm-
saying. We need to have
yeah.
the education piece and the local stakeholders piece guided by the local public health authority. It's a triangle. It's a pyramid.
It is, and the reason that we're spending the time to talk about this instead of just jumping into the research is because
Mhm.
we are the generation that's going to make the difference here, because AI is out of the box, right?
True.
And we know that it's created so many biases.
Hmm.
And it's those of us here with this kind of consciousness, as we develop and do research in this area, we're going to have to show them the difference in how we are more transparent and how we are more ethical in our involvement of doing AI, so that we don't do harm to vulnerable populations, whether they're women, minorities, disabled. It doesn't matter.
But you know
So-
what? There's actually a step that comes before even thinking about AI, and that's thinking about data, right?
Yes.
Because AI is based on data. And what I found, I worked as a senior health data analyst for an HIV organization. And what I found when I would go to meetings is that a lot of other organizations didn't have dedicated data people.
Right.
We talk about, the community. Is there a chief data scientist at the public health department for Fairfax, Virginia? I don't know. I don't think so. Right. So I think even before we start talking about AI, we got to get the data professionals in.
And that's where we're going. So I'm going to go on now and cover
Okay.
some of these topics that you're just now talking about.
Great.
So the next thing is we're going to talk about is the transparency and explainability of AI. When I say this, what I'm trying to say is that we have to share all the processes that we use to develop an algorithm, the data sets we selected, etc., the whole gamut. And that's what Luca and I are going to be talking about in the next 2 sessions, is how do we reveal this process? And that includes what assumptions went into the development of the algorithm. And hopefully I'm going to teach you new tools that are used in AI, like data sheets, data models, data cards. And these are the different ways that we can actually conduct the training and help educate the community and stakeholders, so that they can also support the use of AI, because AI has many, many benefits. And we have to, I think a couple of you made this comment, we have to stop the negativity about it. And the way that we stop the negativity is to stop the harm that it's doing. So these are just an overview of the things that I'm going to cover. And I just want you to understand the differences in the terminology. So a questionnaire is something that you have used in studies, and it can be, and even if you've not done a study using a questionnaire, you've probably filled out census data, or you participated in a study, or it's anything where you ask a question and you get a response. And I'm going to go over each of these in detail. I just want to make sure you understand the differences. A data collection sheet is oftentimes an Excel spreadsheet, and it has rows and columns, and you put your data from the questionnaire into the data collection sheet. And that allows you to be able to do the analysis that you want, putting it in most cases in tabular form, but there can also be narrative qualitative data. This is especially beneficial in AI, in natural language processing, is able to read narratives and create data. A data sheet is something a little bit different than a data collection sheet. A data sheet tells us not only what kind of data it is, but operating conditions, like where you should use this, where you shouldn't use it, guidelines for usage, different performance characteristics, meaning where it was strong, where it was weak. For instance, if you were doing a study and you developed a device and you had real data for all populations, but the poor Alaska Natives who are using synthetic data, you would put that in a data sheet saying that you would recommend that this is not as applicable to Alaska Natives because it was based upon the development of synthetic or the use of synthetic data. So a data sheet lays out all of these sort of pros and cons of the data itself. A data model explains what AI is doing. So it explains the processes, the algorithm, etc., that you use to actually create the tool or the algorithm or the software or whatever you just used AI for. This is important because it helps the user to understand the limitations and the generalizability. Many of you who are doing research, you know what a data dictionary is. It basically defines what the data elements are. And remember, I told you about common data elements and that one of the important parts of common data elements is that they have a concept definition based upon standardized semantics and a code. In a data dictionary, they don't necessarily have to have the code, but it's there. The definitions are there. And then data cards or data sets allows us to see sort of the life cycle of the data set and a quick understanding of what it is. And I'm going to go over this in a little bit different. And model cards also help us understand AI better, including the way that the data intersects with each other as you merge it. And there's many different ways to do this, and I'm going to give you examples of all of this. So these are the types of things that we're going to look at: data sheets, data cards, these kinds of things focused on data. Data cards, model cards, method cards are dealing more with the AI itself. And down here you see the potential users of this information, because these are the people that this is important to in the reuse of anything that you've done. A data sheet, and by the way, you're going to have all this information, so you don't have to worry about catching any of this. I'm going to talk about data sheets, health sheets, and a data card. And a data sheet is dealing with the data. A health sheet is like a data sheet, but it's focused on the health information that was collected. And a data card gives you a nice, quick little summary. So data collection sheets, I told you, this is an example of you use a questionnaire and then you put the information into an Excel spreadsheet. It helps understand what the data categories are. It helps to know what the research reporting will be and analytics. And so it's very easy then to even transfer data to people because it's all in like an Excel spreadsheet. It can be a CSV, it can be all different kinds of files. This is an example of what a data sheet could look like. It gives what is the data type, what were the codes that were used, and what are the responses. So I use race and ethnicity because they have LOINC codes, they have UMLS CUI codes, and they have NCIT codes. The reason these codes are so important is because when I try to aggregate data, I'm going to aggregate them by these codes, not by the semantic of the word. So many of you have probably already created data dictionaries, so I'm not going to go into this a whole lot. It's basically, it tells you a description of the data type, what was the what the label or whatever the data label is, how it was compiled, how it's was used, what is the reuse of it. It has attributes and value domains, a range of responses. You'll see examples of what you can do with this, and this is absolutely necessary for every data collection piece you're going to do. And when you're doing secondary data analysis, every data set should have this, so you should go look at the data dictionary that accompanies that data set, because it's going to tell you about that data set. So you should not use data sets that you haven't looked at the data dictionary and description about, because you don't want to perpetuate bad data. There are many tools to create data sets. This DBMS is just one of them. There are many other tools out there. Some are free, depending on the extensiveness of what you're doing, and some you can pay for. But you take the variable label, tells you the type, the characteristics, and it will build that for you. Notice that it also can tell you whether that data element, in other words, that one variable, was required or not. This is important because this is where a lot of missing data gets confused. So you're sort of the best practice that I'm making a point here is that you always build a data dictionary, and before you use someone else's data set, look for the data dictionary. For those of you who've never done it before, this is an example of the data sheet itself, the data collection sheet, and this is what it would look like changing it into a data dictionary. So notice that here you have date of birth, the client's name, date of birth, gender, marital status, and that becomes the column, and then you describe everything. The field size, the data type. So these are very important for use or reuse. These are examples of the types of things that you can put into data dictionaries. I'm not advocating for one or another. I'm not saying that one is more important than another or that you should always use. This is what you have to make a decision for yourself and the type of data that you're using, so that you know that when a person reuses that data, that it is data worthy for your project. Again, these are other examples. You will have these slides so you can look through them. You don't have to look things up in order to know what are some of the components that you should include. A data sheet is a document consisting of a series of questions, and it's tended to document the motivation, the composition, the collection process, and recommended use of that data set. This is where oftentimes biases occur because data was collected for one form and then it was used for another without that being the intended population. So this is why data sheets are very important, because it also sets what the limitations are to that data set. And by doing this, because remember, there's no laws, there's no rules right now for this, but this is what I always say, CYA. And by having this, and you say, this should not be used, there's not enough data in here for Alaska Natives, so do not use this for Alaska Native generalization. If there's lawsuits that come about, you've covered yourself, because you've had this in place so that if harm is done by using a tool with Alaska Natives, you made it clear that you shouldn't do that. And that's why data sheets are also very important. I'm not going to go over all the structures of this because they'll be in there. And again, it depends upon your data set, the purpose of your research. But When we are doing AI types of research, you should always look for a data sheet. And if there's not a data sheet from a data set or an algorithm that was developed, you go back to the PI, to the original people that did this, and ask for it. Basically, this is kind of a template. These are links for other templates for data sheets. So you have this at your use. Again, I'm not advocating for one type over another. Just be sure that it's clear and concise, that it quickly delivers your key points. It doesn't have to be long narrative, and it helps the reader to understand what is important. This is an example of sort of a timeline of when what you would include in a data sheet, meaning when it started to when the final version was published, so that they understand the range of the data sets that's being used. This is another sort of example of the concepts that you would put into a data sheet. Basically, how was it developed? What questions were established? How did you prepare the data sheets? And what publications actually came from it? Again, I'm not advocating for any one particular one, but I've given you many resources to look up one. So pick something that you feel comfortable with, because when we start this, every one of our projects will have a data sheet, a data collection sheet, a questionnaire. And we will look for these in the data sets that we choose also, if we're looking at algorithms, existing tools out there. This is just examples. You can use the QVR codes to see some of these. I'm going to quickly go over health sheets because they're exactly the same thing as a data sheet, except for it's focused on the health information. The same exact types of information is included on there, but it's specific for health applications. So you have timelines, how was it developed, the general information about dataset versioning, general information. Notice that it's very quick, short information. It does not have to be extensive in narrative. You just have to make the point concisely. This is a quick version of how data sheets and health sheets vary. Like I said, it's pretty much the same information, except for one is dealing more with AI and the other is dealing with health. So let's do a slide up. And what would you like to see on a data set? What questions pop into your mind when you see a data set? What would you want to see on a data sheet or a health sheet? What kind of information would you be looking for? On a data set or an algorithm? So Kevin, will you turn on the Slido, please?
I believe I'm sharing my screen. You should see it now.
Okay. So just again, same thing, type in the information, click on the little things that, the little icon. Again, if you haven't done it, Mark put it in the chat so you can link to it easily. Think about the when you're looking at a new algorithm or a new data set, what are the kinds of things you want to know about that? I'm going to open up the floor again for people to talk. So if you want to talk, unmute. And you can start anytime. Don't be shy. One of the things I always look for when I look at data is how many racial ethnic population groups were collected. And the other thing I also look for is how many, because oftentimes you'll see 10,000 whites, 4 Native Americans, 200 Hispanics. And so you know right away that the data set is going to be very skewed.
Hi, Dr. Duran. This is Tracy Smith. How are you?
I'm good. Hi.
Great. One thing that I was thinking about too, just basically kind of piggybacking on what you were saying in terms of the demographics. The other thing to consider is which sites are being used to collect the data, because if the sites are not diverse, then that probably impacts the population that we're collecting the data from.
Absolutely. Anyone else? These are important things to keep in mind, because this is how, remember, bad data in means bad data out.
So I have a list of questions, who, what, where, when, and why. And I've explained it in here in the answer choices. Who collected the data? What form was it in? Where was it collected? The cloud? Was it a local computer? When was it collected? Why and for what purpose? That's generally where I start.
That's good. And I think one of the points about when is important also, because there are emerging social, political events like COVID that really impact when the data was collected or how. So these kinds of things are very important when we're looking at data sets. By the way, this information will get posted, so feel free to log on or to fill in as much that you can. So I'm going to take the screen back. Can you see it?
Yes, we can.
Okay, so the next thing we're going to go into is data cards. I love this new approach. In fact, as you know, we're building this repository on the ScHARe platform, and we're going to use this approach and using data cards in order to help people to really see what the data is in a very brief way. So in a data card, it's really showing a very simple summary of all the things that were done in developing that data set. So we talked about creating AI-ready data sets and then using that data to create training models, and then in training models to create the end product. So basically what data cards are doing is showing us how that data was used and what parts of the data was used. There's many different ways to do this. It's basically kind of like a data snapshot. That's really the best way to explain what a data card is versus a whole data sheet. These are examples of things that can go on a data card. Again, I'm not advocating for anything over something else. Notice that it has things like authorship, what motivation means, what was your intended purpose, what use of the data set you were using, what methods you used, etc. these are some other examples. Basically, what we're trying to do with data cards is to create transparent data set documentation. And this is the way that we help reusers of the data understand the limitations and the generalizability of what we've developed. It should demonstrate the entire data set development lifecycle. And so the entire way that you created an AI-ready data set and its applicable uses. One of the things that we're going to be advocating for and use in the repository is this idea of kind of like a nutrition label. You know, when you look at the back of a food product, you kind of get what the calories are, the fats, the vitamins, etc. Well, the same thing can happen using a data card that looks like a nutritional value set. So this is an example of one on the right-hand side. For us, we would also include things like race and ethnic categories, health disparity outcomes, whatever they're using. But it is a quick and easy way for a viewer to be able to see a data set without having to go into a lot of detail. This is important when you're looking at hundreds and thousands of data sets, that we have this quick way to see an overview of it. So let's do the Slido again. What would be some of the benefits of using this kind of food label approach to data set? And what else would you include in something like this? I, of course, said race and ethnicity categories. You could also put in the locations. So what are the benefits of having something like this, or the limitations? So Kevin, you have the Slido going?
Yes, I believe I'm sharing my screen. You should be able to see it right now.
Okay. As we're doing this, I'm going to open up the floor also to conversations. So if anyone wants to speak up, what do you think about using something like a food label approach to helping us have a standardized way of looking at or creating data cards? Because remember, we don't have regulations or standardized ways of doing any of this. So just as I said, I'm not advocating for one way or another. Everybody does it a little bit differently, and therefore there's no consistency. And with no consistency, it means it takes you more time to read through all the options in order to get to where you need to be in deciding whether you want to use a data set or not, or an algorithm or not, or a tool or not. So for me, one of the things using something like this is that we get to standardize it so we know what to expect. Anyone else? Any thoughts? Okay, then let's go.
Sorry,
Go on.
I do have a quick question. I'm assuming these would be searchable.
Yes,
Okay, yeah, thank you.
yes. So then let's go to model cards. So I'm going to take back the screen. Can you see my screen?
Yes, we can.
Okay, so model cards are the way that we document what is done for AI models. Again, it's just the way we do it for AI and machine learning. There's no right or wrong way. There's no standardized way. But what is important is that we provide key information on the transparency of how a model was trained and to what audiences was it trained for. There's this paper that has a link that you can understand a little bit more about model cards. And what's really challenging here is kind of what we said about community engagement. You really have to strike that balance between, and this is where it's so important to have multidisciplinary, multi-generational exchanges, which is what we advocate for Think-a-Thons. Because you have to do it in a way that provides the technical knowledge, but in a way that a consumer, a normal person can understand, that doesn't have all the jargon and all the background in data science. So there's that balance and the need for multidisciplinary teams in order to do this. These are some just examples of what data models look like. There's, depending on the purpose, there's many different ones. There's physical, conceptual, there's logical data models. Again, it depends on what you're doing and what you want to convey. What happens is you're basically describing the relationship of whatever the data is and whatever the information is that you're trying to, the assumptions you used to create the algorithm and the training that you employed, and then its general use. These are just examples of model cards. Again, there's no one. This is for GPT. It's training its data set based upon text that is uploaded from the internet, books and different things. Again, no consent was achieved, but this explains how and why it was done. This is how the ChatGPT was started. It's basically semantic language. It's also much of this is open source. And there is this tension, right, between ownership of a tool and then making it available to others because of proprietary or cost benefit. So there are many complexities to this. And so it makes it hard in order to have this kind of transparency, yet still maintain ownership. And this is why it's still a challenge. Again, these are some of the examples of what should go into model cards. Again, I'm not advocating for anything, just keep in mind that it needs to cover all of these things. This is a model card using images. So it's a little bit different than if it was just using tabular data, or the example I used here, which was using semantics or word data. So each of them will look a little bit different based upon what you're doing. So this one is what you would do for images. Basically, what you're trying to do is to show the transparency of reporting, and you can use graphics, you can use words, anything that helps someone understand what you do. We're going to skip this because I think we're running short on time. I want to give you some resources for for doing model cards. Huggy Face is actually a resource. It includes language models as well, not just tabular types of data, but you can, this is a open resource. There's also many different other types of tools that are going to be listed here. When you get these slides, feel free to try any of these different free resources that are available to you. To create a model card, Huggy Face is very easy. It's just you click and it starts to develop it for you, and so you don't have to know a lot of technical pieces to this. This is the kind of information that it will generate. So this is a Huggy Face generation of a model card. And this article actually is explaining the reason that it's so important in creating accuracy, fairness, generalizability, transparency, and robustness. And it all depends upon the use of these model cards to help us understand what is a person is doing in their project. So I'm going to turn this over to Luca now, and he's going to talk about actually the beginning of doing research using this. The point that I just tried to make with you is that it is important to have all of these things in your mindset before you actually start the project, because this is the kind of things that make for transparency. Luca?
Thank you very much, Debbie. Can you all see my screen?
Yes.
Perfect. So I would like to continue to guide you in this journey and explain how the different phases involved in making a research project. So it's really important, it's crucial to select an impactful project topic. To do that, the first thing you have to do is to identify research gaps and opportunities. And there are many ways to do that, of course. So one of them is to conduct a comprehensive literature review of existing research in your chosen field. And you can choose to focus on recent publications, usually from the past 5 to 10 years. And you should identify recurring themes, controversies, and unanswered questions, and potential areas for further investigation or knowledge gaps. And you should also try to identify the limitations of the existing studies to analyze, methodological limitations or unexplored variables or, inconclusive findings that warrant further research. And of course, those of you who are researchers know this is mainly for the coders and the programmers among us who are trying to acquire new skills. So another way to do that is to leverage Google Scholar or other academic search engines to explore current research trends. And there are, of course, many effective search strategies that you can employ to refine your results. You can use relevant keywords and phrases. You can use Boolean operators such as and, or not, and advanced search features, of course. So filters, for example, offered by these search engines to refine results by publication date, author, or other specific fields. And finally, something that could also be of interest is using patent databases, which offer insights into technological advancements and can also spark research ideas. So the aim here is to use those databases to identify novel technologies, potential research gaps, and unmet needs. Great. So once we have identified a research topic, it's time to talk about the data. So choosing the appropriate data set is critical, of course, for the success of your research project. And there are many factors that you should consider when selecting the data set. The main one is relevance, of course. So you should ensure that the data set aligns with your research question. So that research question needs to be clearly defined, of course. And once you analyze data sets, you have to identify the variables needed to address it. And in terms of quality, you should also assess the data that you're choosing for accuracy, completeness, and consistency. We'll get to that. And you should check, of course, for missing values, outliers, and inconsistencies in the data. So there are so many quality checks that you have to conduct. And then in terms of accessibility, of course, you have to determine if the data set is publicly available or if it requires permission for access, etc. And you can, I would actually recommend that you explore data repositories and platforms relevant to your field of research to locate more of those data sets. So another thing that is really important is the in-depth analysis of the data set that you're choosing before selection. So you have to try to understand data characteristics such as data quality. So if the data is complete, consistent, accurate, representative, as we said, if it's suitable, so if it aligns with your research question or model objective. And also you should try to explore the data to gain insights into the data distribution, relationships between variables, and potential patterns through various techniques like visualization, summary statistics, etc. And if you do that, these analyses can also allow for informed decision-making. So based on your analysis, you could decide to refine your research question, for example, based on the limitations that you have identified, or to seek alternative data sets that better suit your needs, or to implement data cleaning and pre-processing techniques to address those issues that you have identified. And then, of course, you could also think of doing some feature engineering. So if the analysis can inform decisions about creating new features from existing ones, so potentially enhancing model performance if you're working to develop an algorithm or a model. And in terms of model selection, you can understand the data characteristics, and that helps choose appropriate machine learning algorithms or statistical methods for your analysis. And I just want to point out that ScHARe is actually a really good place to start with if you're interested in conducting some SDOH-related research. So on ScHARe, you can explore the available data sets to identify potential resources. And you can actually see a screenshot from the platform right here. And we saw this many times together in the past webinars. And I'd like to remind you of the categories that comprise the shared data ecosystem. So we have Google-hosted public datasets, which are publicly accessible, federated, and de-identified datasets hosted by Google, actually, through the Google Cloud Public Dataset Program that we make available through ScHARe. And an example is the American Community Survey. And we also have ScHARe-hosted public datasets, which are publicly accessible, de-identified datasets that ScHARe hosts. And an example is the Behavioral Risk Factor Surveillance System. And finally, we have ScHARe-hosted project datasets, which are mainly funded program and project datasets from NIH using core common data elements. And here, I gather some examples of interesting datasets from the Google-hosted category. So you can see that besides ACS, you have US Census data, you have, for example, point in time homeless count, you have Medicare, and many COVID-19 data sets. And there are many, many interesting options. And I'd also like to give you some examples of the ScHARe-hosted datasets, which are organized based on the CDC SDOH categories with the addition of health behaviors and diseases and conditions. And as you all know, of course, the social determinants of health, I don't need to repeat that probably, but they are the non-medical factors that influence health outcomes. So they are the conditions in which people are born, grow, work, live, and age. And you can see the social determinants of health listed on the screen. So education access and quality, healthcare and quality, neighborhood and built environment, social and community context, and economic stability. And again, we added health behaviors and diseases and conditions to these. So we have more than 240 data sets, and I'll give you some examples of data sets that we host for each category. So for the education access and quality category, we have data on graduation rates, on school proficiency, early childhood education programs, interventions to address developmental delays, etc. And you can see some of the examples listed here. For the healthcare access and quality category, we have data on health literacy, use of health IT, emergency room waiting times, preventive healthcare, health screenings, treatment of substance use disorders, family planning services, etc., access to care, and access to health insurance, for example, adequate oral care or prenatal care, STD prevention measures, etc. So you get the idea, and you can see some examples listed. In terms of neighborhood and built environment data, we host data on access to broadband internet, access to safe water supplies, toxic pollutants, and environmental risks, so air quality, blood lead levels, deaths from motor vehicle crashes, asthma, etc., and noise exposure, smoking, mass transit use. In terms of social and community context, we do host data on crime rates, imprisonment, resilience to stress, experiences of racism and discrimination, etc. Economic stability. We have data on unemployment, poverty, housing stability, food insecurity and hunger, and work-related injuries, for example. In terms of health behaviors, we host data on health-related practices that can directly affect health outcomes, and birth is one example that I cited earlier. And finally, we have data on diseases and conditions, so on the incidence and prevalence of specific diseases and health conditions. And you can see some examples here, like the US chronic disease indicators. Finally, I'd like to remind you of how you can actually access the data available on ScHARe. So most of you, I guess, are familiar with the ScHARe workspace. So you can recognize it on screen, and you know that there are several tabs on the top. From the Analysis tab, you can access a list of notebooks, and the first one is called List of Datasets Available on ScHARe. So that notebook lists all of the datasets that we make available. And another way to actually access the data directly is from the Data tab. So if you go to the Data tab in the ScHARe workspace, data tables will help you access shared data. And you can see that, as I said, the data sets are organized based on the CDC categories on the left. So you only have to click on each category, and on the right, you'll be able to access each individual table and more information on each data set. Just wanted to remind you of how to actually access the data available on ScHARe. And another important aspect that I want to underline today is common data elements. So you all know by this point, I guess, we had an entire event on this. So common data elements are standardized data elements used in research studies. So they are standardized ways of asking a research question with a set of allowable responses. And basically they are, as I said, standardized questions which are asked the exact same way in every study that adopts those common data elements. And this allows the use of these data to better understand diseases and disorders and to map across data sets. So to give you an example, if we are asking about someone's age, we could ask that question in several ways. So we could ask, how old are you? And the answer would be a number. Or we could ask, when is your birthday? And the answer then would be a date. So if we standardize our way of asking that question, and we always ask, for example, what is your age? Then the answer is always going to be, for example, 34 years old, right? Or that's going to be the format of the question, and it's going to be the same for every study, allowing for a series of benefits, right? So the findings will be more easily comparable, and there will be reduced redundancy, of course, because by using standardized elements, researchers avoid collecting the same data repeatedly. And then data quality will also improve because usually CDEs come with clear definitions and standardized formats, so errors are minimized as a result. And then it will also be much easier to facilitate data sharing. So because CDEs promote open science, of course, by enabling researchers to share and reuse data efficiently. And I want to show you the labels of the ScHARe common data elements, which are published in the NIH CDE repository. You can actually check it out. The link is in purple on this slide. And so as you see, there are two data elements that are bolded here, NIMHD framework and health disparity outcomes. Those are project level common data elements. But all the rest, you can see that we have age, birthplace, zip code, race and ethnicity, sex, gender, sexual orientation, marital status, education, annual household income, household size, and then some of those social determinants of health, some more, right? So English proficiency, disabilities, health insurance, employment status, usual place of healthcare, financial security and social needs, self-reported health, and health conditions and associated medications. So those are were actually approved, endorsed by NIH. And they're published now in their repository. So I would invite you to check them out. And why should you check datasets for CDEs? Well, that promotes compatibility and collaboration, right? So when you're selecting a dataset, it's good to check if it utilizes CDEs relevant to your research field. And look for, of course, for information about those specific CDEs used in the dataset, their corresponding variable names. And of course, if the dataset doesn't use CDEs, of course, consider the potential challenges when you will be trying to compare data with other studies. So what are the benefits of using CDEs? Well, one of the benefits is the opportunity for merging the data sets, which can unlock valuable insights, right, and enhance research power. So you can try to assess when you're trying to see if you can merge the data sets. You can try to see if the content overlaps. So whether those data sets share similar content areas or address related research questions. And you can also try to compare the variables, if they compare the variables in the two data sets, and check if they have comparable definitions and formats so that you can meaningfully merge them. And you should also check if the timeframes covered by each data set actually align for meaningful integration. And finally, you should also try to identify data sets offer complementary information that can actually enrich the combined analysis when the two data sets are merged. So those are some criteria that you can keep in mind when you're trying to merge data sets to expand your research questions. And then, of course, there are also challenges when merging data sets. So keep those in mind as well. There could be data quality discrepancies, of course. So, of course, you have to ensure that data quality is addressed before trying to merge the data sets to minimize biases and inconsistencies. And then harmonization can be difficult, of course, especially when there are very different data elements and formats. And then, of course, you have to keep in mind that there might be ethical considerations. So, for example, in terms of informed consent or data privacy or responsible data sharing practices. So those are the aspects that you may want to keep in mind. And now I would invite Kevin to please share the screen, because we have a poll and we would like to understand, given that we saw so many benefits that the adoption of CDEs brings about in research, and we'd like your opinion in terms of which factor or factors present the biggest obstacle to the widespread adoption of CDEs in your field, in your research. So I give you some time to answer. And Kevin, if you can also display the results so that people can start voting on them if they agree with some of the options on screen. Yeah, I agree. Lack of interoperability among vocabularies, for sure. Exactly. Yes, institutional and agency silos where policy and protocols are concerned. Yep, semantic differences in representing the same concept. Yeah, once again, there are harmonization problems between institutions. Yeah, obedience. Yeah. Let's see. I mean, could you please sort them?
I like what somebody said about semantic differences.
Mm-hmm.
That's why we use CDEs,
Mm-hmm.
so that they have codes.
Exactly. Yeah, and it is an evolving field. That's true. It's not well understood. Perfect. Thank you so much. Thank you, Kevin. We can close it. Thank you. So let me go back to my slides. Perfect. Then the next step, once we have selected the data set and we have considered whether it's using or not CDEs, the next step is to make that data AI ready. We had an entire event on this, so I'm trying to summarize here the main concepts. And making datasets AI ready involves ensuring them that they are suitable for use in machine learning and AI applications. So there are some key aspects of AI ready datasets. So one is data quality. So we must ensure that data is accurate, complete, and consistent. And we should address also missing values, outliers, and inconsistencies that could impact model performance. And then data cleaning and pre-processing as well. So there are techniques that we can apply, like normalization, scaling, and coding to prepare the data for machine learning algorithms. And then, of course, feature engineering. So sometimes we have to create new features from existing data to improve model performance. And then another really important part, as Debbie stressed earlier today, is documentation. So providing clear and detailed documentation about the data set. Perfect. So that said, why quality checks are essential for AI-ready data? Because poor quality data can lead to biased models. So if the data is representative or skewed, that can lead to models that perpetuate existing biases and can produce discriminatory outcomes. We'll see that in a moment with some examples. And then, of course, poor quality data can also lead to inaccurate results because it can cause models to learn incorrect patterns and generate unreliable predictions. And then poor quality data can also lead to wasted resources, of course, because now we are training models on low quality data, and that's a waste of time, computational power, and resources. So quality checks encompass various aspects, and they are categorized into these key areas. So data completeness, which includes missing values. So of course, the identification and handling of missing data through imputation or removal. We'll see about that in a moment. So how we actually deal with missing data. And then outliers. So if you detect unusual data points that might skew model training, so how to address it. And then data consistency. So in terms of format, in terms of units and labels. So of course, we should ensure that data formats are consistent across the entire data set, and units of measure and data labels are also consistent. And data accuracy, of course. So in terms of both verification and validation. So verification means, of course, cross-checking data with reliable sources to identify incorrect errors. And validation means comparing the data we have against expected values, right, to all the our domain knowledge to ensure accuracy. And data representativeness, of course, which is about generalizability of the findings, right, from using that data, and about bias. So about analyzing the data for potential biases in sampling, labeling, or other aspects, as we will see in a moment. And then, as I said, really important, data documentation. So in terms of both versioning, so maintaining clear versioning of the data to track changes, and also metadata. So in terms of providing comprehensive information about the data and collection methods, usage guidelines, etc. So here is some sort of a checklist for AI-ready dataset quality checks that you can keep in mind. And we discussed about every single one of those items. And then, of course, quality checks for AI-ready datasets, as we said, are really important. And I would like you to, well, actually, Debbie, you discussed this, so I guess, but data, of course, I mean, should be complete. Yeah, you discussed this.
We can skip through this.
Yes, I'd say that we can, in the interest of time, we can. And data dictionaries, as Debbie said, very important. So this is about the time when you should really think about completing that documentation at this point in your research project. And let's see how you can address missing data once you identify it. It's actually a very common challenge in datasets, and there are many strategies to handle it. But before I get into the strategies, let me tell you that there are several ways, several types of missing data, right? So data could be missing completely at random, which means that missing occurs randomly and is unrelated to any other variables in the dataset. Or it could be missing at random, meaning that it depends on observable variables in the dataset, but not on the missing values themselves. Or it could be missing not at random. So in this case, it is related to the missing values themselves, often due to unobserved factors. But once you identify it, how can you deal with it? So there are several strategies. Maybe one is deletion, and there are several ways of deleting variables that have rows actually that have missing values. So you do that with listwise deletion. And that means removing entire rows with missing values. The negative aspects about that, of course, are that you are potentially reducing sample size and you're also introducing bias potentially. Or you can also do pairwise deletion, which removes only the data points with missing values for the variable being analyzed. But again, in this case too, you are potentially wasting information. And the other technique to deal with missingness, with data missingness, is imputation. And there are so many ways to do that. So there is, for example, mean, median, or mode imputation, which involves replacing missing values with the average, median, or most frequent value of the variable. And again, really simple, but may introduce bias, especially if the distribution is skewed. And then there are so many other kinds of imputation. So there's hot-tag imputation, which replaces missing values with values from existing observations with similar characteristics. Potentially it introduces noise, of course. And then model-based imputation. So the difference here is that you use statistical models like regression or machine learning to predict missing values based on other variables. And computationally expensive, of course, but potentially more accurate. And then, of course, mean or median imputation. Yeah, we said that. Perfect. That's a repetition action. Perfect. And of course, there are also several other things that you have to deal with, because not all research questions may have readily available data for every variable. So when that happens, researchers may need to employ proxy variables, right? Or navigate situations with small sample sizes, simply. So there are strategies that you can adopt to address proxies and small sample sizes. In terms of proxy variables, you have to be very careful in selecting proxy variables that are demonstrably linked to the desired variable. And of course, you have to be mindful while doing that of potential limitations and biases. And then if you are faced with a situation where you have a small sample size, then there are techniques, there are statistical methods that you can use to analyze the data that are designed for small data sets, such as non-parametric tests or bootstrapping techniques. So you can deal with that appropriately. And finally, I just want to mention, I know that Debbie has talked about this before, but synthetic data generation involves creating, as we said, artificial data that resembles real-world data, but protects privacy and confidentiality. And it offers certain advantages, but it also raises ethical considerations that you have to address. So these ethical considerations have to do with transparency and disclosure. So you have to clearly communicate that you're using synthetic data, including the number of actual people used to generate it, right? And you have to acknowledge the limitations of its use to avoid misinterpretations. And then other ethical considerations have to do with responsible use. So synthetic data should be used ethically, right? So you need to ensure that it doesn't perpetuate harmful stereotypes or results in discrimination. And then potential biases. So you have to be mindful of generalizability limitations and potential biases that might be introduced during the synthetic data generation process. And you have to take steps to mitigate these factors. So in general, you have to avoid perpetuating bad AI, and you have to mitigate biases in data sets. And this is especially important because nowadays algorithms are being used to influence decisions affecting people's health. And algorithms rely on data. And if the data is biased, of course, the output of the algorithm is going to be biased. And data sets can actually perpetuate bias if they contain these biases reflecting societal inequalities or discriminatory practices. So really, algorithms run the risk of replicating and amplifying human biases, affecting protected groups in particular. We said that many times. And bias can actually originate from many factors, so from unrepresented or incomplete training data that reflects historical inequalities, or it can also manifest at various points in the algorithm development process. So you can see some examples here, right? So there's data-driven bias, but also algorithmic bias from imbalanced classes or training bias, and then human bias from societal prejudices and power imbalances. So when these are combined in the training of the algorithm, of course, the output risks to be biased. And some examples of these, I'll only give you one example, the most famous one, right? So machine learning was used to create a computer decision support system that was helping dermatologists diagnose between benign versus malignant moles. And the problem here was that lesions on patients of color were less likely to be diagnosed by the system. And the problem was that the algorithms were being trained on a repository of skin images from primarily fair-skinned populations. So bias in this case was emanating from unrepresented trained data that was reflecting historical inequalities because, of course, clinical research had focused for decades primarily on people with light skin. So the solution in this case, when the problem was identified, was to try to expand the archive to include as many skin types as possible. But this is just one example of the potential consequences of biased data. And since we have these consequences, it's especially important to avoid, right? Perpetuating bad AI and to mitigate bias in data sets. So we should try to identify potential sources of bias, both in data sets and in algorithms. And when we have identified them, we should try to utilize bias mitigation techniques. And there are many. I'll mention some of them in a moment. And of course, really important is transparency. So promoting transparency and responsible AI practices, always through documentation that is appropriate and transparent. So I'd like to give you just a brief overview of methods that you can use to test for biases in datasets and then in algorithms. So in terms of datasets, there are many. One is exploratory data analysis, which involves visualizing and summarizing the main characteristics of the dataset. You can do that using histograms, box plots, summary statistics, but the goal is to understand the data distribution, to identify outliers, imbalances, and biases. And I'll give you an example. If exploratory data analysis reveals a dataset on job applicants is heavily skewed towards a specific gender, then we might have a bias in the sampling process. And you can see also listed some Python libraries that you can actually use to conduct exploratory data analysis in your computations and in your analysis. Another technique is demographic analysis, which is about breaking down the dataset based on demographic attributes, such as age, gender, ethnicity, and analyze the distribution within each group. And you do this to identify imbalances or overrepresentations in specific groups that can lead to bias. So, for example, in a healthcare dataset, if we have one demographic group that is overrepresented, that may lead to biased predictions, as we just saw with that example. Data stratification is another technique. It's used to divide the dataset into subgroups based on relevant features, and then you analyze each subgroup independently. And this helps detect biases that may exist disproportionately in specific subgroups. I'll give you an example. If we have a credit scoring dataset, if we stratify by income levels, that can reveal biases in credit approval rates. These are real cases. And finally, very important, bias detection tools. So there are ready-made tools like IBM's AI Fairness 360 or Google's What If tool. And these tools offer automated metrics for assessing bias in datasets and models. And they're really easy to use. They facilitate a systematic approach to bias detection. And for example, Google's What If tool allows interactive exploration of model predictions and visualization of outcomes across different subsets of data. It's really well done. I would invite you to check it out. Both of them, actually, and there are many more. And then in terms of fixing biases in datasets, there are several techniques, right, that can be employed to address bias in datasets. So one is oversampling or undersampling. So we would be increasing or reducing the representation of certain groups in the dataset to ensure that the distribution is more balanced. Or again, another technique is the use of synthetic data, as we said, right? So introducing these artificially generated data points with all the risks that we just saw. And then reweighting or adjusting the importance of specific instances during model training. That also helps address bias. And then updating and expanding data sets. That's really important with diverse representative samples that can contribute to minimizing bias. Perfect. And then that was datasets. In terms of algorithms, there are, again, several techniques that you can use to test for biases. So one is performance metrics disaggregation. It consists in evaluating model performance metrics, so for example, accuracy or precision, separately for different subgroups that are defined by sensitive attributes such as race, etc. And the importance here is that disparities in performance metrics across groups may indicate bias. So if a healthcare algorithm is more accurate for a certain race than it is for another, that can reveal bias. And possible fixes include root cause analysis and adjustments to the algorithm. Another technique is confusion matrix analysis. So confusion matrix, as I'm sure you all know, is a table that summarizes the performance of a classification algorithm. And it compares predicted and actual values, right? So if you analyze the confusion matrix for different subgroups, you can possibly identify disparities in model predictions And that is particularly important for false positives and false negatives. And finding disparities in errors can pinpoint areas where bias may exist. So an example here could be if you are analyzing a medical diagnosis algorithm using a confusion matrix and you're evaluating the model's effectiveness in making those medical diagnoses. If there is a difference in false positives between genders, that might indicate bias. And then the fixes would include adjusting decision thresholds or retraining the algorithm with balanced or more balanced data and consulting domain experts, of course. Finally, there are fairness indicators that you can use. They are measures that assess whether models' predictions treat different groups equitably. And you can integrate these fairness indicators into the model evaluation process to identify bias. So in a structured approach to actually measure bias. And an example of these indicators is Google's TensorFlow fairness indicators. And of course, possible fixes include retraining the algorithm with balanced data and adjusting decision thresholds. And finally, sensitivity analysis. So sensitivity analysis is about assessing how changes in input features impact model predictions. So you tweak one feature at a time and you observe the model's response and how the response changes. And that can help identify features that disproportionately influence the model, may potentially leading to biases. So an example could be if we have a healthcare decision support algorithm that is trying to predict diabetes risk. With sensitivity analysis, we can try to assess how variations in input variables, for example, age, BMI, impact predictions for different racial groups. And so that can allow us to identify whether the algorithm is disproportionately relying on a single variable that maybe is affecting certain groups disproportionately. And the fixes here include recalibrating the model to minimize the influence of that variable, or retraining, for example, with a more diverse data set. And counterfactual analysis, actually, that involves exploring hypothetical scenarios by determining the minimal changes that I need to make in input features to alter a model's prediction, right? So this helps researchers understand the model's decision boundaries. So I'll give you an example to make it a little more, a little clearer. So in a credit approval algorithm, if a loan application from a certain racial group is denied, the analysis can involve identifying the minimal changes needed in the application features. So for example, the minimal changes needed in income or credit score to get an approval. And so that can shed light on potential biases. And again, the fixes here are about adjusting the decision thresholds or mitigating the impact of sensitive features or retraining the model. So that was it for our overview on bias in datasets and algorithms. And at this point, thank you, Kevin. I'd like to hear your opinion. So what are the biggest challenges that you face in your personal experience with research in ensuring that the data sets you're using are truly AI ready, beyond the technical aspects that we have seen? I mean, are there any other challenges that you're facing? I'd like to hear your opinion on that. And Kevin, if you can display the results as soon as they are ready. Yeah, need for local training. Yeah, we've heard that so many times, that, right? Need for training and practice. Yeah, balance them will represent the data. Yeah, most of the time.
And Luca, you can open it up for conversation too.
Sure, of course. Of course, please feel free to intervene. Okay. Yeah, practice. need for more diverse sampling. So you're highlighting problems in the data or with insufficient training, which is consistent with what we keep seeing. Lack of interdisciplinary collaboration, often necessary with complicated issues and data sets. Access to local AI subject matter experts. Who are they and where are they? So again, lack of training and access to those skills and resources. That's great. Let me see here. More diverse people involved in the process from data collection to analysis makes a big difference. I agree. We agree completely. That's what we are trying to do with this initiative. Perfect. Anything else? Yeah, for training. Perfect.
I think one of the things that I would like you guys to also address in the Slido as well as in person, if you want, is the missing data part. Oftentimes are in sort of preparing AI-ready data sets, we have such an imbalance of the inclusion of racial and ethnic groups. One of the things that have emerged to deal with that missing data is synthetic data. But what are ways that you think that we can deal with the missing data or small sample sizes that Luca presented as we're trying to get these data sets AI ready?
Can we verbally give a answer?
Of course.
Yes, absolutely.
I think this is based on my own research. I think one of the things that can be done when you have missing data is if you use social determinants of health information, I think that's a real good marker for how you can impugn data points that are missing. So for example, if you're talking about a person that comes from a specific zip code, and you know in that zip code they don't have a whole lot of healthcare, and you have someone else that lives in that same zip code, but you don't have any information about their healthcare access, you can infer, you can make some informed educational decisions about, based on, you know, someone else that also lives in that same zip code around the same social determinants of health. So that would include like education level, you know, access to healthcare, transportation options, income. It's not perfect, but I think because it's so difficult, generally speaking, to collect data from people from marginalized communities, that again, if you use information that you gather from the social determinants of health, that's one option. I'm not saying it's the best option. I'm just saying it's better than throwing the data away or, you know, deleting rows and things like that. Just a suggestion.
Yeah, no, these are the kinds of things that we need to discuss because they're real life challenges. One of the things that I recently learned was when we don't have people's exact addresses and you have a zip code, kind of doing what you just suggested is that we, instead of using PII or that kind of sensitivity PII, to create neighborhood profiles. And in the neighborhood profile, you don't necessarily link it to any one person, but you create a profile of education level, grocery stores, alcohol stores, you know, whatever assumptions you want to look at. So that these are other kinds of strategies when we don't have information specifically. So that's why I wanted to ask what people can do, because this is a real life problem.
Oh my God.
And we try to mitigate these things, and they're becoming more of a problem as we use these bigger data sets. I'm somebody was talking?
I, so agree with you because I'm so challenged with the area that I deal with the homelessness and the people that I serve as a harm reduction specialist, a peer recovery person, myself in long-term recovery, but coming back in my community to serve with the harm reduction because of the substance use disorder that is killing our folks like in droves here in New Jersey where I live at. So trying to get that type of data, oh, it's a huge challenge for me. That's all I got to say.
It is, and this is why I want to open up the floor to discussion about how to sort of deal with some of these small sample size, hard to get vulnerable populations, because without this information, AI is going to move forward and it's not going to benefit our vulnerable population groups. Any other suggestions or challenges? There's a comment in the chat.
Mhm.
And this is oftentimes what we do is if there's missing data, you just take it out of the data set or not use that data set. But again, I'm going to stress that that's a standard practice that has always been done. And consequently, we don't have results always that benefit all the population groups, because if there hasn't been enough information, they just dump the data. And then different population groups don't get addressed. Whether it's Wanda, I think, was the one who just said homeless population. But that often happens to the Native Americans and Alaska Natives or the Pacific Islanders, because there's always not enough data when these big data sets are getting collected. And we need them to benefit from AI as much as everyone else. So how do we rectify this? One of the ways that has emerged because of AI is synthetic data. But what other kinds of ways do you think that we can address this issue? Your point is true. It could, no data may cause less harm, but it also, no data could cause more harm. So you're in a catch-22, right?
There's one comment in the chat about reporting the missingness for upstream correction. So for example, at the collection point, remove unequal access to services, etc.
So one of the things that at least to pay attention to when you're doing this kind of research using big data sets and AI, this is something you have to pay attention to. It's something that is important not to just ignore, because it has lots of implications in applications where they assume that it is generalizable to everyone, but it wasn't developed by everyone for everyone. So we just need to make sure that we pay attention to this, documented in our work. And when people want to use things like synthetic data, then how do you document that use? So Luca, you want to move on?
Sure, of course, we are almost done, actually. We are at time. And I just wanted to point out that now, by this time, we should hopefully have a research project, right? So it's time to define our research question, which forms the foundation of our entire project. And to be good, a research question needs to be specific, feasible, So, achievable within the constraints of the data you have and the resources you have. And then measurable. So it must allow for data collection and analysis, and relevant. So it must address a significant gap in knowledge, or, it must have practical implications. And then, of course, your secondary analysis project is, ready to be launched, and you have to define research question names really clearly. And these are a reminder of all the phases that we have seen. And it's especially important to utilize ethical practices throughout the research process. I want to stress that in particular. And that said, next time we'll see how to select computational strategies, how to test, the algorithms even in the implementation phase, and then how to publish open science. We'll talk about that, and we'll talk about our upcoming research think-a-thons, and we'll try to brainstorm some projects together with you. And that's it for today. So I leave some resources that we offer in the slides that will be distributed and published online. And I leave these for later. And I would like to thank you for being with us today. And Debbie, I leave it up to you to launch the final evaluation poll. Thank you, everyone.
We ask that all of you fill out the survey for evaluation, because it helps us to plan and to improve. So please do so. I like what Catherine just put into the chat. Become wiser about using data. That is our point. We very much have to become wiser about using data. And for those of you who want to be involved in the research, next session, we're also going to start planning what kind of research questions that we'll start to ask, and form research groups. So please join us next month as well. And we'll continue many of these challenging conversations about data use, reuse, and misuse. We're going to leave the survey open to you, even though we closed the session, so you can still
So thank you for joining us today. Thank you so much.